Hello friends, welcome back. I am Rajneesh and today in this session we are going to understand device mapper multipathing. As the name suggests, multipathing simply means you have more than one paths to reach to the shared storage. In our lab environment we are going to use SCSI target based SAN that will be using iSCSI protocol, but in your corporate environment you might be using fiber channel or host bus adapters to connect the fiber channel to the SAN. So finally, if we are talking about the SAN, it's actually logical unit numbers or LUNs which are exported to the servers. So in case you are using a single connectivity between the client and the SAN, and that connectivity gets lost because of any of the reason, either host bus adapter gets faulty or your fiber cable goes faulty, so there will be no connectivity with the SAN, and finally your application may not work. So that is the reason we should have multiple paths to connect to the same LUN. That is known as multipathing. So it simply means you have more than one host bus adapters and more than one fiber channel cables that are going to connect this SAN to the client that will be importing this LUN. The same happens with iSCSI target and iSCSI initiator. We will be connecting iSCSI target to the iSCSI initiator using three networks in our environment. The reason is multipathing. So due to any reason, if one of the network fails, the NIC fails or the cable is disconnected, the LUN that is exported will still be accessible through other channels. So till the time you have one channel working or one cable or one interface that is working fine, you will be able to access your LUN which is exported by your SAN. So what is multipathing? It is the ability of a server to communicate with same physical or logical block storage. Same means you have created the same LUN and the same LUN is accessible by the client through multiple networks or multiple paths. Communicate with the same physical or logical block storage device across multiple physical paths between the host bus adapter in the server and storage controller for device, typically fiber channel or iSCSI SAN environments. So what does it provides? It may provide fault tolerance. So even in case this goes down, still your data will flow and the disk or the LUN will be accessible. It may provide you load balancing. Some data goes through it, after that some data goes through it. It provides load balancing across active connection, provides connection fault tolerance, automatically isolates and identifies device connection failures, and reroutes IO to alternate connections. So as soon as one of the connection goes down, other connections will be used to send the traffic to that particular LUN, and effectively that block device will still be accessible and you can continue working on it and your application will not be impacted. Okay, so for example, as you can see in the lab, I'll show you there. So here what I wanted to show you is you can have here you can see these are multiple path groups. Then you can see this is of more priority 200. So finally this will be used, and we have two devices inside it which are active and in ready state. We have two devices under priority 40 which are also active. So device to be used. Okay, this is also important question that we are going to see the same thing in the lab. If we are creating or installing multipath, so it creates a device dev dm dash n dm1 dm2 dm3. So these devices should never be used directly because they are intended to be used by DM multipath tool. For example, if we are trying to format a multipath device, we should never format DM-N device. So every time make sure that we are using dev mapper and then the device name to format it and to mount it. The reason being it's persistent and it's available in the early stage of the boot process. Okay, coming on to the lab, to demonstrate this we have created two virtual machines. One is infra.labs and other is going to be desktop 10. So let me log in into it. Okay, so if we have a look into this machine, this has three virtual interfaces or three physical interfaces actually. 192.168.10.254, 12.254 and sorry, one should be 11.254. My mistake. Okay, so let me correct it. It is 11.254. It's 12.254. Let me try to restart the service. Uh, Looks fine. And one more thing, if you are talking about server, your network manager should be stopped, and let me switch off the service. Let me try to restart networking. Okay, ETH 0, 10, 11.254 and 12.254. The network interfaces are fine. So the first thing that we are going to do is on the infra or the server, we are going to install iSCSI or SCSI target utils. Mount dev cd-rom on media yum install target utils. And coming on to our client machine, the IP address is 12 dot something in all. Let me correct it. If CFG 0, and I'm going to set it to fine. ETH1 interface is ETH1, looks fine. ETH2 looks fine. So I'm going to stop network manager. Network manager is actually uh, here you can see an icon which you can use to configure your networking, basically used for desktop. So I would never recommend using it on servers. Let me restart networking now. Okay, so 192.168.10.10, 11.12, 11.10 and 12.10. So the networking is fine. On the client end, I'm going to install yum install iSCSI initiator utils. Let me open a session to the server from here only. SSH root at 192.168.10.254. So yes, media. Okay, this is actually the VirtualBox add-ons, so I have mounted the wrong DVD. Let me just remove it, cancel. Let me unmount it, and now I'll mount my CD drive. Okay, so first one, let me mark infra server. This is the server on which iSCSI target is installed, and this is my client on which iSCSI initiator is installed. Okay, so first thing is, let me configure tgt or targets.com. Before that, fdisk -l. I can see that I have SDA, SDB and SDC. Okay, fine. So B and C are blank. /etc tgt targets.conf. So just to understand the topic, we are not going much into the security this time. We are just going to create two LUNs. Okay, let me use this as a template. Yank and paste. I'm going to use backing store dev sdb, and name that I'm going to give it is 2013 March. I'm going to mark it as disk 1, yank 2 and paste. I'm going to mark it as disk 2, and the disk is going to be dev sdc. So here I create two targets with the different names ending with disk 1 and disk 2, each having single LUN which is SDB and SDC. So effectively, this infra server as a iSCSI target is going to export two LUNs. I write and quit. chkconfig tgtd on. And just to confirm, tgt admin minus s. So here you can see that we have target 1, which is exporting disk 1, and which is the disk 1, this is dev_sdb. Coming on to target 2, ending with disk 2, it's exporting as ln1, it's exporting dev_sdc. So finally our iSCSI target is now set up. Now, which is the port that it uses? It uses 3260. So let me allow it through firewall. IP tables minus I, input minus P, TCP minus minus D port minus J accept. So now this iSCSI target accepts port 3260 from all the networks. So it should be accessible from 192.168.10.254, 11.254 and 12.254. Now etc iSCSI initiator name, let me change it. Desk 10, and or I can just name it like desk 10. Okay, the other part is slash etc init.d iSCSI restart. If fails, we can do force start. Okay, so now I am going to scan iSCSI ADM minus minus help minus, okay, let me see, man, or iSCSI ADM minus M, mode is discovery DB, minus minus portal, the server on which iSCSI target is running, 192.168.10.254 colon 3260, minus types and targets, minus minus discover. And here if I ran the discovery DB, I found that if I am trying to log in into this portal, I can see this two LUNs. One is corresponding to disk 1 and one is corresponding to disk 2. Why these are two? Because I created two targets, target 1 and target 2, both having different names. This is target 1 and this is target 2. So these are the two targets that were exported by infra server. So okay, in the first instance let me discover it corresponding to all the three network interfaces. Sorry, it should be 12. So in these three commands, what I have done is I have run a discovery DB on 192.168.10.254, 11.254 and 12.254. These are the three network interfaces present on this infra server or iSCSI target server, ETH1 and ETH2. So corresponding to each of these portals or each of the IP address 11, we can see that it's exporting the same LUNs, disk 1, disk 2, disk 1, disk 2 on 10, on 12, disk 1 and disk 2. Finally, if you create a picture of it, you will come to know that you are reaching to the same two LUNs, which is disk 1 and disk 2, through these three paths 192.168, 10.254, 11.254, and 12.254. Okay, so till now we have discovered it but not yet logged into it. Let me log in into it. adm minus m node minus minus portal minus target name capital T, that comes out to be disk 1 minus L to login. So right now I am logged into 10.254 disk 1 here to a different network 11.254 disk 1 and 12.254 disk 1. So through all these three network interfaces I am logged into first LUN. Now I'll log into the second disk through 10.254, 11.254 and 12.254. After I am logged into these three, or effectively uh, these three networks and two disks or two LUNs corresponding to every network, I should be able to see around 6 new disks. So here you can see div SDB, div SDC, D, E, F and G. So finally 1, 2, 3, 4, 5 and 6. You have 6 new disks. Why 6 disks? Because you already have 2 targets present over here, and these 2 targets or 2 LUNs are exported through 3 networks 192.168, 10.254, 11.254 and 12.254. So actually there are 3 paths to the same disk 1 and disk 2. So here we can see all the 6 new disks. Second part is now configuring multipath. So let me install the required packages. Yum search multipath, because I am not sure exactly what the name of this package is, so I can install it now. Yum install device mapper multipath. So this I am doing at the client desk 10. So now the required packages are installed. The second part is we have to load DM multipath, which is a module. So mode probe DM multipath, ls mode. Okay, so we have loaded distributed mapping multipath module. Now we should be able to interact with the multipath devices. The second part is to create a configuration file multipath.conf, which is not yet present. So what I'm going to do is I can use empath config command. So user friendly names, no. Okay, user friendly names means the names that will be visible to you will be like empath A, empath B under dev empath. So they can be understood easily and won't be complicated. But the thing is that it may not be unique if you are talking about multiple nodes accessing the same multipath device. So we are going to use the ID corresponding to them, which is going to be consistent in case you have number of nodes which are using the same shared storage. So it creates your multipath.conf file. Let me Okay, so you have the initial multipath conf now, slash etc multipath.conf, because it's going to use multiple attributes. So I would like to show you. Okay, man is not there. Yum install man. Man multipath.conf. Now we have created a sample configuration file, which is slash etc multipath.conf. We have loaded the module, which is dm multipath. So final part is to restart the service, but before restarting we need to understand how we want to create the multipath devices and which all devices should be excluded. So to understand this, let's come on to the section. One is corresponding to the default, which says user friendly names no. Let's just comment it as of now and make use of the file or the section which is already present for default. I just uncomment it completely. So here is the default section, which says if I am creating a multipath corresponding to any of the device, what should be the default attributes of it. So first thing, as I already suggested, is user friendly names no. It simply means how to create the device names. They won't be like empath A or empath B. Rather, they are going to make use of the ID. So which is the ID that they are going to use? That they are going to fetch out using this command, where percentage %n is going to replace your actual device that you get. For example, let me create one more session. So iSCSI ID minus minus whitelist all and the name of the device. For example, I type SDF over here. So this command is going to return the iSCSI enterprise target and then its ID. Let me try to compare it with the others that I am getting. So here, this is corresponding to the first target and this is corresponding to the second target. We can try comparing it with tgt admin minus s. And here, if you have a look into it, the SCSI ID of first learn in target 2, this is target 2, and here you can see that the SCSI ID is IET 00020001. Okay, one more thing that you can see in the controller corresponding to target 2 is there is one initiator that is logged into it, which is desk 10, which is the IP that it is using 192.168.110.10. It has one more session from different IP 192.168.11.10 and the third one is 12.10. So finally the desk 10 machine has created 3 connections to it using the 3 networks from the IP address 192.168.10.10, 11.10, and 12.10. It has logged into and it is accessing the same device, which is dev-sdc on this target server. Coming on to target 1, here we can again see that there are three connections from three different IP addresses of desk 10. So finally these three connections are trying to access the same disk on infra server, which is going to be dev sdb, and the SCSI ID is IET, this one, 00010001. So okay, coming back over here, so I think you can understand that these are the three connections that be using the same learn dev sdb. So this is multipathing of three network, three connections from disk 10 to the same disk on infra server. Okay, user friendly names we are setting it to no. So the names are going to make use of uh, your worldwide ID or your ID SCSI ID. So SCSI ID I was able to fetch using the command minus minus whitelisted to whitelist all devices and specifying the device. Now you can see that there is some white space in between. If you use this command, you are going to get some mysterious characters, 00x or some hex characters, which are going to replace this space. So it would be best if you can just remove spaces. There is an option, remove spaces, sorry, SCSI SCSI ID. So it's replace white spaces. Replace white space. So using this command you were able to get the ID, SCSI ID of your LUN. So let me just add this part over here. So okay, now let's understand the default options. udev directory, it specifies the directory of udev under which the device will be created or your mapper device will be created. Polling interval, this is the number of seconds after which it is going to check every path whether that path is active or not. So after every 10 seconds it checks a path whether the disk is accessible or not. Selector, it defines which is the algorithm that you are using to send the data to select which path is to be used to send the data to. Round robin 0 says all the paths that are present inside a multipath device will be used in a round robin fashion, which simply says load balancing. So in case in our scenario we are using three paths, 192.168.10.10, 11.10, and 12.10. So there are three paths accessing the same block device dev sdb. So in our scenario it will be using all these three paths to send the data to in a round robin fashion. Path grouping policy, it means how will the path groups be created. Inside a single multipath device you can have multiple path groups. By default it makes use of multibus, which says all of your paths will be present inside the same group device. So all the paths will have the same priority. if you have any issue with any configuration attribute, you can just have a look into man-multipath.conf. So defaults is the section which says which are the default attributes in case not specifically specified for any WWID. There is one section, okay, coming on to defaults first. Polling interval between two path checks in second, UDEV directory, the directory under which devices will be created, multipath directory under which the dynamic shared libraries are present. Find multipath, if you set it to yes, this machine is going to find out the multipaths to a particular device. It is going to scan all the devices and it can figure out which devices have multiple paths to it. Verbosity path selector, which the default path selection algorithm, so round robin, loops through every path. Queue length 0, which says the next data or the next bunch of IO is to be sent to the path which has the least blocks in queue, so which is almost free or which has less data in the queue, that will be used first. So send the next bunch of IO down the path with the least amount of outstanding IO. Service time 0. This algorithm says whichever queue is fast, try to send the data to that one. Choose the path for the next bunch of IO based on the amount of outstanding IO to the path and its relative throughput. Path grouping policy. It could be failover. Failover means there will be one path per priority group. Okay. For example, uh, if you have a look into this multipath output, here you can see that you have two devices under this path group which is of priority 200. This is actually group by priority. So here you can see two paths under priority 200 and two paths under priority 40. So there are actually two groups, group 1 and group 2, and effectively it's the same multipath device. So it is having multiple groups inside it. Different groups have different priorities because we are grouping them by priority. So here first one has priority 200, second one is having priority 40. So and in this case there are more than one devices attached to every priority group. So the priority, how is it defined? Okay, uh, priority is defined depending upon the hardware that is used. Here is the option that we can use to set out the priority for the devices. By default, it's constant, which sets priority 1 to all the paths, and we are going to use this constant method in our lab for iSCSI. It can be different for EMC or ALUA. So depending upon different hardwares, it is able to fetch out the priorities of that. And high priority means this is the first to be used. So we can group the paths on the basis of priority, one priority group per priority value. We can group the paths by node names that they are trying to fetch the data from. We can group them by serial number, and there is one option multibus which is the default, which says all paths are going to be in one priority group, and failover says there will be only one path per priority group, and one path will be actively used, and if that path goes down, the lower priority path will be used. Get UID. How to get the UID or the WWID of the disk that for which we are going to create a multipath device. So this is the command that we have already specified. Priority, we are going to use, was it constant or static? I just forgot. It's constant that we are going to use. Path checker. How does this device mapper multipathing comes to know that the device is dead and no more accessible? Read sector 0 means it'll try to read the first sector and will decide whether that device is up or not. So read sector 0 says read the first sector of the device to make sure that it's usable or not. Round robin minimum IO. Minimum number of IOs that are to be sent to a single path before shifting to the other path, because we are using multibus, so we can have, or we actually have all the paths in the same path group. So first, minimum number of IOs that are to be sent to one path before moving to the other path. Maximum number of file descriptors 8192, that is fine, you can increase them. Round robin wait is priorities, let it be default. Failback. Failback means, okay, it tells multipath daemon how to manage path groups. Okay, immediately fall back to the highest priority path group that contains active path. So failback, it means whenever your active priority path is down, what should be the action that should be taken. So immediate here says as soon as multipath daemon comes to know that this particular path is down, immediately fail back to the highest priority path group. The path group whichever has the highest priority, you can move to that. Manual, do not perform automatic failback if you want to set it. And value greater than 0, deferred failback, time to defer in seconds. So you can specify the number of seconds over here. No path retry. Okay, it means that in case the device is not accessible or there is no path to the device, so how many times or for how much seconds should it retry? Uh, no path retry. Specify the number of retries until disable queuing. Setting it to fail for immediate failure. So queuing will be immediately stopped as soon as it identifies that this device is down. And user friendly names, that the name should not be like empath A, empath B, rather they should use their ID, which will be fetched through get UID callout. Coming on to the other section, which is blacklist. Mm, uh, Let me remove this part, or let me just remove it. Okay, blacklist. This means that which are the devices for which I don't want this multipath D to check for multipaths. So here you can specify WWID, corresponding to which it is not going to create a DM device. you can select the device node, for example the device slash dev slash ram x. DM device will not be created corresponding to it. Similarly, these are either it's starting with ram or raw or loop. We are going to just not create a multipath device corresponding to these devices. And if you want to just remove, or you don't want to scan HD devices to check out for multipaths, you can just uncomment this. So this simply means caret start with HD A to Z. So whichever IDE device is attached directly to your server, multipath D is not going to check that for multiple paths. There is one more option, multipath exception, if you can see, because you can set blacklist WWID, it could be set to star, and you can just specify blacklist. uh, there is one option to blacklist ignore or something like that. Blacklist exception, where you can just exclude the variables that are excluded, or that okay, let me give you an example. Blacklist, I can set it to WWID star. It says all the WWIDs will be blacklisted, and it is not going to create a multipath device corresponding to any WWID device, or corresponding to any of your SAN device. After that, you can just write this command blacklist exceptions, and in this section you can specify the specific WWIDs which will actually be whitelisted even if they are present in blacklist. So this is exception. Blacklist exception are the exception to the blacklists. So we are not going to use it. Okay. So I think we are done with it. Save it, quit. init.d multipath d restart. So previously it was stopped, so it's fine. chk config multipath d on. Okay, now if I have a look into multipaths, so the command that can be used is multipath -ll to list. Here it says there is some issue with multipath.conf in line number 35, and some issue with selector, line number 35. Rather than selector, it should be like path selector. Let me just confirm. Yes, this is path selector. So this is actually, you can say, a bug in the configuration file that was created. Multipath restart. Okay, now if I run multipath ll, I cannot see any multipath device. Okay, let me see the SCSI status. iSCSI status. iSCSI is running. I cannot see any device in multipath. Minus increasing the verbosity. Increasing the verbosity, I can see the devices SDB, CDEF, but In case they are still not visible, there is some issue with my multipath.conf that has blacklisted SD devices. Let me see blacklist section. So okay, RAM devices are blacklisted, loop devices are blacklisted. Dev SDA is, this is your host number, bus number, target number, LUN number. So DM01 are blacklisted. SDB not found in path AVC. Let me reboot this machine. Switching on chk config, iSCSI on, iSCSI D on, and multipath D on. So it's going to take a few more seconds. Okay, now if I see multipath LL, I cannot see any multipath device. Multipath D is running, and fdisk minus L grep. Okay, I can see the devices. There is some issue with multipath.conf. Let me try out this command. Okay, yeah, I got it. My mistake. It should be whitelisted. My mistake, sorry. Let me just restart multipath D. Yes, so now you can see that this is your first iSCSI target. This is your second iSCSI target. Let me just log in into SSH root at 192.168.10.254 tgt admin minus s. And if I have a look into it, target 1 has these 3 sessions with it, and its ID is IET 00010001, IET 000001, and for the second target and first learn, it's 00020001. Fine. So let's try to understand it now. This is your iSCSI enterprise target. The size of this block device is 1 gig. If you want to confirm, dev SDB and SDC are the one that are exported, so it's around 1 gigs that you can see over here. So the size of effective size of this multipath device is 1 gigs. Policy, we specified round robin. Priority, we set as constant, which takes priority 1. Okay, so here you can see that there is a group single path group under which all the 3 devices are present. Means your 3 connections to the iSCSI target, which are going to the same disk or the same LUN, are coming under the same multipath device, and your multipath devices that are created are dev mapper 01 and 02. So effectively these are the 2 devices that are to be used by any user or application, and these devices are working as multipath devices. Behind them there are actually 3 physical hard disks or 3 connections to the same disk. The same is happening for the second multipath device. So your multipath device is this one, and each multipath, for example this one, is having 3 connections to the same device on iSCSI target. Right now you can see that the status is active, ready, and it's running. Now if you want to work or you want to install application on this multipath devices, so how will you do it? So the first thing is you need to format it, and make sure that when you are formatting it you are making use of dev mapper and your this unique ID rather than using dev empath and empath something or dev dm0 or dmn. So we have to make use of dev mapper and this one. Okay, so let's create a new partition, primary 1. Let's create it for 250M, right? And now part probe this device. Now you have created one partition inside it, so you'll be able to see one more device which ends with P1, which says the first partition. Now we are going to format this first partition using ext4 file system, and we are going to mount it under slash, let's say learn 1 to have consistent entry so that it is available or mounted after every reboot, we are going to create an entry of it in etcfs tab. Your device, it's going to be mounted under learn1, and the type of file system is ext4 defaults underscore netdev, because it has dependency on network, as this is using iSCSI initiators to connect to the target. Sorry, 00 dump and fsck write and quit. So mount slash. Okay, so here you can see that all the three are running and active over here. The same is happening for this case. I have created one partition on first iSCSI target, and I have mounted it under learn1. Now if I try to write some data in it, I am able to write. Now the next part that I am going to do is I am going to disconnect the cable of one of the interfaces. I disconnect the cable, click on OK, and now coming back to the station or the client, I write the command multipath ll minus v3 for verbosity. So here you can see, corresponding to device dev sdc, it tries to get the state and comes to know, okay, config file default checker timeout is 30 seconds, state is blocked. Okay, the other thing in the meantime that you can see is tail minus f var log messages, and here you can see kernel reported iSCSI connection 6 error, iSCSI connection failed. So it says 192.168.12.254 portal is not available, there is no root to host. So finally, does it completes? Not yet. Let it wait for the timeout, and it's not able to connect. iSCSI D is not able to connect to this portal, and effectively you have lost one connection to the disk. And still df minus h cd, here you can see the data. Okay, wait for the timeout. You should be able to write to it, you should be able to read. Okay, so finally, if you have a look into this multipath ll command, here you can see that your device dev sdd has now failed, and it's now faulty because it's not accessible. And the same has happened for your device sdc, which has connection has failed and it's now faulty. The reason being, we have just plugged out the cable for that interface. So I tried to create a test file, so test2 is here. So So here you can see that I am able to write to slash learn partition, which is using a multipath device even in case one of the device has failed. So you are still able to write to it. If we just connect this cable once again, so in the next few seconds you will see that this failed and the faulty are going to set to active and a ready state. So here you can see now your device is back to up state. So this is how your multipathing works. Just to recall, there are multiple paths to the same iSCSI target. The paths are SDD, SDF, SDG. Other thing to be noted is we made use of iSCSI ID, which is going to be consistent. So if we are talking about any cluster node and we have the same configuration across the clusters, so we are not concerned about what exactly the name will be, because the name is going to be corresponding to your iSCSI target ID, which is going to be consistent and which needs to be consistent or same across all the nodes. In case you are going to use uh, this option user friendly names to yes, the names could be different in the cluster nodes depending upon which multipath device is created first. So it's never suggested to switch it on. Let it be no in all the cases. So this is how multipathing works. Mm, yeah, so I'm done with it. Thanks for viewing the video. Have a great day.